Hey guys, welcome back to Sleepy Science Stories, the only channel where you can fall asleep and accidentally become the most interesting person at brunch. Tonight, we're heading somewhere emptier than your WhatsApp group chat after you suggested splitting the bill evenly, the vacuum of space. Out there, your tears would boil off your face before you even finished crying about it. But don't worry tonight, the only thing that'll evaporate is your sense of linear time. We're unraveling one of the universe's oldest mysteries. Why do planets orbit? Why don't they just fly off, crash into the sun, or call it a day and become space debris? Is it gravity, momentum, a fear of commitment, or a cosmic group project nobody can leave? If you enjoy drifting through space and time with us, consider liking, subscribing, or even commenting, but only if you actually enjoy this, and only if you're not already asleep. Now, dim the lights, put on a fan for that spaceship vibe, and settle in. And while you get comfy, ask yourself, what would it feel like to wake up in orbit? Would you get dizzy? Would your phone still get notifications? Would your body keep circling the fridge? Or would you finally escape the gravitational pull of midnight snacks? Tonight, you'll find out sort of. Ready? Let's float away. Tonight, you find yourself groggily blinking awake on a spinning cosmic carousel, feet dangling in space, held in place not by seatbelts, but by the mysterious invisible hand of gravity. Welcome to planetary orbit, where falling never means hitting the ground, and your hair looks like you stuck a fork in the universe's electrical socket. Let's set the scene. You open your eyes to find yourself floating above a blue and white marble, the Earth, dazzling, silent, and so close you could almost boop it with your nose. Only, you're not falling, you're not even standing, you're weightless, tumbling end over end around the world like a stray sock in a cosmic dryer. There's no up, no down, and absolutely no hope of finding your slippers. The first thing you notice is the silence. Not just any silence, but a kind of soundless vacuum that makes even your thoughts feel like they're echoing. No traffic, no snoring partners, no suspicious late-night emails from your boss. Just you, the infinite dark, and that one, weirdly comforting spinning sensation like waking up on a merry-go-round that never, ever stops. Out here, you are the amusement ride, and the universe is charging admission. So, how does it feel? Imagine you're falling, but the ground never arrives. Every second, gravity is tugging you toward Earth's surface. But you and everything else up here are moving forward so fast that you keep missing it. You are falling around the Earth, not down to it. If this sounds suspiciously like the excuse you use for missing deadlines, I'm not late, I'm orbiting the concept of punctuality, then congratulations, you're already thinking like a planet. But don't panic. In orbit, your stomach stops trying to crawl out through your mouth after the first 15 minutes. Your brain, ever the multitasker, adjusts. Eventually, floating starts to feel normal, and you accept that every snack you open will become a cloud of floating crumbs, a decision you will regret immediately when you realize you're about to inhale the world's first orbiting pretzel. Let's talk sensations. Your arms drift above your head, your legs float out at odd angles, and every small push sends you spinning gracefully, like a very confused interpretive dancer. You'll notice the sunlight blazes brighter, and the shadows are absolute. One side of your face is bathed in light, the other is plunged into cosmic night. And yes, you can see your house from here, but you still can't find your car keys. The view, by the way, is ridiculous. Every 90 minutes, you circle the world. Cities glitter, storms swirl. Sunrises and sunsets whip past so fast you could get jet lag just from blinking. On the bright side, it's impossible to miss the morning meeting up here. On the downside, your body clock stops trusting you entirely. Day, night, Monday, Thursday, it all blurs together in the world's most spectacular screensaver. And then, reality sets in. Your hair, now rebelling against the tyranny of gravity, puffs out like you've been electrocuted by a very determined physics teacher. Every sip of water becomes a science experiment, Every sneeze a slapstick routine, and every yawn a reminder that, out here, oxygen is a privilege, not a right. You might start to wonder, what would happen if you just let go? Would you drift off into the black, finally free of emails, laundry, and existential dread? Not quite. The merry-go-round never stops. Gravity's grip keeps you moving, always falling, always missing, forever circling the globe like the world's least reliable boomerang. And so, you float, not falling, not flying, just orbiting, endlessly, absurdly, in the greatest carousel ride the universe can offer. No ticket required, no exit in sight. Congratulations. You are officially part of the cosmic merry-go-round, and your next stop? Nowhere. Because out here, the ride never ends. Gravity isn't just a force. It's that emotionally needy ex who insists you never leave their side. Here, in the vastness of space, you're being pulled, nudged, and endlessly clung to by the biggest object in the room, like a party guest with the world's worst FOMO. Let's get real. Gravity is the ultimate cosmic Stage 5 clinger. It doesn't matter how many boundaries you set, how fast you run, or how convincingly you say, it's not you, it's me. Gravity will always find a way to keep you close. It doesn't text you at 3 a.m., but it does send a subtle, unending invitation to stay, forever, within reach. Earth's gravity wants you so badly, it warps the very fabric of space-time just to hold you tighter. Talk about commitment issues. Picture yourself in your childhood home, except instead of your mum nagging you to clean your room, it's the Earth quietly nagging every atom in your body, every second, forever. No matter how high you jump or how wild your dreams of space travel might get, you'll come back down. Maybe not today, maybe not tomorrow, but eventually you always end up in gravity's embrace. Even astronauts on the International Space Station are not free. They're just falling with style. But what actually is gravity? Let's dim the lights and get pseudo-romantic. Gravity is the curvature of space and time, a gentle, invisible push-pull woven into the fabric of the universe. Imagine you're at a party, and the biggest, most magnetic guest walks in someone with serious main character energy. Everyone in the room feels it. People are drawn closer, some more than others, depending on how close they stand or how much they weigh. In this metaphor, the Earth is that guest, and you, my friend, are just a humble canapé, destined to hover nearby. Gravity doesn't take breaks. It never forgets to text you back. It doesn't even sleep. Drop your keys, and gravity catches them every time. Drop your motivation, and gravity still holds your body in bed just a little longer. The force is everywhere, quietly persistent, never letting you drift too far off course even when your thoughts do. But if you could somehow press mute on gravity, just for a second, things would get weird fast. You'd be gently yanked off the ground like a misbehaving balloon at a parade. Your coffee would float, your dinner would float, your socks still mysteriously unpaired would float, and you'd finally have an excuse for why you never finish chores. Sorry, gravity called me away. You might be wondering why gravity is so clingy in the first place. The answer is mass. The more mass something has, the more gravity it exerts. Earth, being the chonky blue orbit exerts a lot. The sun, even clingier. Black holes, the absolute worst. Nobody escapes their pull, not even light. In the cosmic yearbook, gravity wins, most likely to never let go. But for all its clinginess, gravity is also fair. It doesn't care if you're a bowling ball or a loaf of banana bread. Drop them, and they fall at the same rate. Galileo proved it by throwing stuff off a tower and probably getting some weird looks. Gravity, for all its drama, treats everyone equally, unlike some exes you know. And yet, if you move fast enough, you can cheat a little. Rockets blasting into orbit don't escape gravity, they just find a loophole. Move forward fast enough, and you're always falling, but never landing. You're still in gravity's DMs, but now you're leaving them on read. In the end, gravity is the universe's way of saying, we're all in this together. You, me, the planets, your cat, and that half-eaten sandwich you forgot in the fridge. All gently, relentlessly, held by the same invisible force. So next time you feel stuck, just remember, it's not you, it's gravity. And honestly, it's not letting go anytime soon. You're suspended between worlds, locked in an endless game of cosmic tug-of-war. On one side, gravity yanks you inward. On the other, your motion desperately tries to escape. Spoiler, nobody wins, and you're left circling forever, just like your most persistent overthinking. Let's paint the picture. Imagine you're the rope in a gigantic game of tug-of-war, but your opponents are invisible and impossibly patient. On Team Gravity, the Sun, the Earth, or whatever cosmic heavyweight happens to be closest, pulling you with relentless, silent determination. On Team Momentum, your own stubborn tendency to keep going in a straight line, like a bowling ball launched in a universe with no gutters. The result? You move forward, gravity pulls sideways, and you end up taking the world's slowest, laziest left turn for eternity. If you've ever been in a group project where everyone wants control, but nobody actually wants to do the work, you're halfway to understanding orbits, you're not going anywhere new, you're not settling down, you're just stuck in a loop of maybe tomorrow. In this way, the universe is extremely relatable. So, what's really going on here? Physics, of course, but not the kind that requires a chalkboard or, heaven forbid, math. All you need to know is this. The only reason you don't crash into the Earth, or the Sun, or your neighbor's satellite dish, is because you're constantly moving forward fast enough that every time gravity tries to reel you in, you sidestep it. It's like running down a hill so quickly that, instead of tumbling to the bottom, you keep missing the ground by just enough to stay upright. Terrifying but effective. Now, let's bring this home with a classic metaphor. Imagine tying a tennis ball to a string and spinning it in a circle over your head. The string is gravity, always pulling the ball toward you, but the ball wants nothing more than to fly off in a straight line, except the string won't let it. As long as the ball keeps moving fast enough, the game goes on. If you let go, it shoots off into space. If you slow down, it plummets to your face and your glasses. In orbit, the tennis ball never leaves and never hits, just endless, perfect compromise. You might be wondering, doesn't anybody ever win? Nope. This is a tug-of-war with no winners, no finish line, and no trophy except the existential awareness that you're stuck in a cycle of cosmic procrastination. It's less of a game and more of a status quo. A celestial group chat where everyone's seen the last message, but nobody's replying. And what about you, suspended in this eternal struggle? Your body starts to understand the stakes. Your stomach floats, your bones feel light, and your inner ear gives up on sending helpful updates. You exist in a limbo, a state of not quite falling, not quite flying, a subtle, unending tension between two forces that refuse to break up, for your benefit, or possibly their own amusement. Of course, this tug-of-war is happening on a planetary scale. Every second, the moon plays it with Earth. Earth plays it with the Sunday. The Sun, in turn, is caught in the Milky Way's invisible grip, orbiting the galactic center like a distracted goldfish. Even the far-flung comets, those ice-cold rebels of the solar system, are stuck in their own slow-motion rounds, yanked by gravity, pulled by inertia, never quite leaving, never quite arriving. The irony? This game, with its endless circling and no clear winner, is the reason you have a stable home planet, a gentle sunrise, and tides that know when to show up. Without it, there'd be no seasons, no calendars, and no excuse to tell your boss, "Sorry, I was just lost in orbit." So, next time you're caught between forces at work, in life, or in your own mind, remember, sometimes the most stable place is right in the middle of the laziest tug-of-war in the universe. Ever wonder what would happen if you sprinted so fast that every step took you around the Earth before you could faceplant? That's orbit. Tonight, you're the ultimate procrastinator, running sideways so fast you never have to deal with falling. Newton would be proud. Let's picture it. You lace up your sneakers, limber up your hamstrings, and prepare to sprint around the Earth, not around the block, not through airport security, but literally around the entire planet. But here's the catch. You never touch the ground. Every time you're about to fall, you've already sprinted so far sideways that the ground has curved away beneath your feet. Falling, but never landing. The ultimate avoidance maneuver. Welcome to the most glorious loophole in the universe. If you go sideways fast enough, gravity can never quite catch you. It's like running from your responsibilities with such relentless determination that you actually circle back to them over and over, forever. This is Orbit, the world's most prestigious act of perpetual procrastination, endorsed by Sir Isaac Newton himself. Newton, as legend has it. Imagine this with a thought experiment involving a cannon on a tall hill. If you fire a cannonball gently, it falls back to Earth like your motivation on a Monday morning. Fire it harder, and it lands farther away, like your hopes after another round of just one more episode. But if you fire it just right at a sideways speed of about 28.0 kilometers per hour, the cannonball keeps missing the ground forever. Congratulations, you've achieved orbit, and possibly a Nobel Prize for creative avoidance. Let's break this down in human terms. Have you ever tripped, but caught yourself with a stumble so dramatic that even gravity had to pause and admire your form? Imagine extending that stumble around the entire planet. Every moment, gravity pulls you downward, but you keep moving sideways fast enough to dodge its grasp. Your fall becomes a smooth, endless glide. It's like riding a roller coaster with no hills, no valleys, just perfect, eternal sideways motion. This might sound exhausting, but in space, you don't even need to keep running. Once you reach that magical speed, inertia does the work. Inertia is physics' way of saying, as long as nobody bothers you, you'll keep doing exactly what you're doing, which, if you're orbiting, is not falling, not flying, just coasting sideways at ludicrous speed. What does this look like from your perspective? Imagine running along the rim of a gigantic bowl. Every step tries to bring you closer to the center, but you're going too fast to slide down. Instead, you whip around, feeling a strange lightness in your limbs, a gentle tug toward the ground that never actually wins. If you slow down, you'll spiral inward and finally hit the ground. Speed up, and you might escape entirely, flying off into deep space like the world's most determined lost sock. Now, in real life, you can't just run your way into orbit unless your jogging routine includes a rocket launch and $1 million spacesuit. But the principle is the same for astronauts. Their spaceships aren't hovering, and they're not falling in the usual sense. They're running sideways around the planet at dizzying speeds, perfectly matching gravity's pull so that falling and moving blend into a seamless, weightless experience. If you ever wondered why astronauts float, now you know. It's the universe's reward for running away from the ground with perfect timing. Orbit is a delicate dance, a partnership between your sideways sprint and gravity's relentless reach. Too slow, and you're a meteor. Too fast, and you're out of here. But just right, and you're locked into the most satisfying loop, running forever, never tripping, never touching down, just gliding, endlessly, above the fray. So next time you're tempted to dodge your problems by sprinting sideways, just remember, somewhere in space, a planet is doing exactly the same thing, and it's been working out pretty well for a few billion years. Let's travel back to that fateful day under a suspiciously aggressive apple tree. Sir Isaac Newton watched an apple fall and thought, what if it missed? Suddenly, the secret to orbit was born, and so was every science teacher's favorite fruit anecdote. You're there now, lounging in the shade with Newton himself. He's not checking his phone, he's sketching weird diagrams in the dirt and looking suspiciously at his snack. The apple falls because gravity, but instead of just eating it, Newton spirals into that classic scientist move, overthinking everything to the edge of reality. He wonders, not, Why does the apple fall? But what if it kept missing the ground? What if instead of dropping onto my wig, it just circled the earth forever? Cue the world's first "Wait, am I the drama?" moment, starring gravity and motion. Newton realized the same force pulling apples to the ground also keeps the moon circling the earth, the planets moving around the sun, and your favorite mug locked in an abusive relationship with your kitchen floor. Suddenly, physics wasn't just about things dropping. It was about things endlessly almost dropping and never quite arriving. This insight is the birth of Orbits the Apple as cosmic metaphor. If you've ever dropped your phone and watched it hit the floor with the full force of Newtonian inevitability, you've already experienced gravity's day job. But for Newton, gravity wasn't content with ruining breakfasts. It was the invisible puppet master, orchestrating a universal dance, apples, moons, planets, comets, all forever in motion, all forever falling, but sometimes with enough sideways speed to keep missing the ground. Let's make this absurdly clear. If you could throw that apple hard enough sideways, not down, it wouldn't just land a few feet away, or even in the neighbor's garden. With the right speed, it would fall all the way around the earth, coming back to where it started, hopefully without hitting Newton on the head twice. This, in a nutshell, is an orbit, falling endlessly, but never arriving. Of course, Newton never actually launched an apple into space. He was a genius, not a fruit vandal. But his imagination did what rockets would do centuries later. He pictured a world where the same simple rules, gravity, inertia, motion, apply everywhere. Suddenly, the universe wasn't a random pile of cosmic clutter. It was organized, lawful, elegant, and all because of a lazy afternoon snack. And it wasn't just apples. Newton realized that the same gravitational force rules everything, everywhere. The moon isn't glued to Earth. It's moving sideways fast enough that it's always falling around us. The Earth does the same around the Sunday. The Sun, in turn, is pulled by the Milky Way. It's cosmic Russian nesting dolls, each layer forever falling, forever missing. So, next time someone brings up Newton's apple, don't just think gravity. Think sideways falling. Think orbits. Think of a universe where everything is just barely not crashing, thanks to the right blend of motion and pull. It's like cosmic yoga, everything finding its balance, holding a pose for billions of years, never quite letting go. Newton's realization gravity plus sideways motion equaled orbit changed everything. No longer were planets just stuck in place by angelic pushes or mysterious ether. They were on cosmic merry-go-rounds, obeying the same rules as your lunch or your socks. The magic wasn't in the apple, it was in the question, what if it missed? And so, with one good question, and possibly a bump on the head, Newton turned a snack into a revolution. Now, every time you see something fall, or better yet, something not fall, remember, sometimes the universe's deepest mysteries are revealed by asking the laziest, weirdest questions under a tree, and by imagining an apple with a really impressive sideways arm. 3. If you've ever thrown a paper airplane that narrowly missed your coworker's head, congratulations, you've unlocked the secret of orbits. Planets are expert missers, always falling toward the sun but always missing, doomed to a life of beautiful, organized avoidance. Let's be honest, missing things is usually a bummer. Miss your exit, miss your deadline, miss your one shot at karaoke glory. But in the universe, missing is an art form, a cosmic ballet of almost, nearly, not quite. Orbits aren't about getting where you're going. They're about never quite getting there at all. Picture yourself standing at the edge of a field, paper airplane in hand, channeling all your unspoken childhood ambition into one perfect throw. You aim, you launch, and the little plane arcs through the air, not in a straight line, but in a graceful curve. Maybe it flutters, maybe it soars, maybe it just nosedives spectacularly, but for a moment, it's falling and flying at once, missing the ground by a hair's breadth with every inch it travels. That's what planets do, but at an entirely different scale. and with much less paper. Each world is hurled through space by the legacy of its formation, carrying enough sideways speed to miss the giant flaming catastrophe at the center of its solar system, the Sunday. Every second, gravity tugs, beckons, tempts. But every second, the planet's motion says, "Not today, Sunday, not today." It's the most high-stakes, low-drama game of keep-away you could imagine. This is the essence of orbit. The planet wants to fly off in a straight line, to make a dramatic exit, but gravity's always pulling it back in. If you could freeze time, you'd see that every moment is a near miss, like that plane gliding by your co-worker's ear, close enough to cause a breeze, never close enough to cause a meeting with HR. This is the universe's greatest magic trick. Falling forever, but always missing. Let's break down the mechanics. If a planet didn't have enough speed, gravity would win instantly, yanking it into the sun in a blaze of glory and melted sneakers. If it had too much speed, it would break free, shooting off into the cold abyss, never to be seen again, like a paper airplane caught by a rogue breeze. But just the right speed, and you get that perfect sweet spot. The endless near miss, the art of almost but not quite. It's not just the planets either. The moon is an expert at missing the Earth. Every day, it's pulled toward us by gravity, but its sideways momentum is perfectly calibrated so that it keeps missing, looping around and around, lighting up our nights and occasionally going all in on dramatic eclipses. Satellites, comets, even space junk, they're all artists in the gallery of organized avoidance. And what about you, the human observer? If you ever find yourself aboard the International Space Station, or just in bed, watching astronauts float in zero gravity on YouTube at 2 a.m., you're witnessing this same principle in action. Astronauts aren't weightless because gravity took the day off. They're constantly falling toward Earth just fast enough to keep missing it. Their orbits are a masterclass in planned avoidance, a cosmic almost repeated 16 times a day. But let's get philosophical for a moment. Isn't the art of missing just a little bit relatable? How many things in life do we spend our days circling, always close, never quite arriving? Dreams, goals, old friends, that gym membership from January. Maybe orbits are the universe's way of saying it's okay to keep circling, to keep missing, as long as you're moving with purpose, or at least with style. So next time you launch a paper airplane and miss your target, or find yourself endlessly circling the parking lot for a spot that never opens up, take comfort. You're channeling the same cosmic principle that keeps the planets spinning, the moon shining, and the world from crashing down. You too are a master of the art of missing. Planets aren't prisoners, but they can't just walk out on the sun either. There's no cosmic HR to file a complaint. Instead, they're locked in an endless dance, compelled by invisible rules that nobody voted for. Welcome to the universe's weirdest relationship. Imagine, for a moment, you're at the most awkward family wedding in cosmic history. The sun, resplendent in blazing formal wear, stands at the center of the solar system dance floor. Around it, the planets shuffle in neat, predictable circles, not because they want to, necessarily, but because leaving is complicated. Each world, from Mercury, the eager overachiever, to Neptune, fashionably late, is bound by the unspoken laws of physics. Nobody can ghost this party. Not even Pluto, which, after its demotion, still shows up, just in case there's cake. So why don't planets just leave? Why doesn't Earth, on a particularly bad Monday, call it quits and head for the cosmic exit? The answer, as usual, is gravity, the sun's powerful, invisible invitation to stay. But it's not a jailer. It's more like that charismatic dance partner who never breaks eye contact and always knows the next step. Planets are pulled into a routine, each at its own distance, locked into patterns so reliable you can set your watch by them, or at least plan a solar eclipse party years in advance. If a planet wanted to escape, it would need more than motivation. It would need speed, a lot of speed. This is called escape velocity, the cosmic minimum wage for getting out of the sun's gravitational field. For Earth, That's about 42 kilometers per second, or roughly the speed your heart would have to beat to make you actually enjoy cardio. Anything less, and you're stuck doing laps forever. Your sideways sprint just fast enough to miss crashing, but not fast enough to bail on the relationship entirely. But here's the twist. Unlike people, planets can't just try harder. They're stuck with the energy they started with, the leftovers from the solar system's formation. No midlife crisis, no new sneakers, no impulsive haircut is going to get them out of this arrangement. If the sun is clingy, it's only because physics made it so. Now and then, something dramatic does happen. A rogue asteroid, a passing star, or some cosmic collision might throw a planet off course. If a planet somehow gained enough energy, it could pull off the ultimate breakup and leave the solar system for good, a cosmic wanderer destined to drift through the darkness, telling everyone at the galactic bar about its free spirit phase. But this is rare. Most planets just stick to the dance floor, swapping stories and subtle gravitational nudges. So what's it like to be a planet in this relationship? You get front row seats to all the sun's biggest performances, flares, sunspots, the occasional dramatic outburst. You bask in the warmth, ride the seasons, and maybe complain a little when things get too hot or too cold. But you always come back for the next revolution 1 year after another, for billions of years. There's a kind of comfort in this cosmic routine. The sun never moves, never leaves, never changes its rhythm. The planets glide, sometimes wobble, sometimes bring a +1, hello, moons, but always return to the pattern. It's not prison, it's persistence. Not confinement, but cosmic choreography. If you ever feel stuck in a routine office meetings, family group texts, the same commute day after day, just remember, even the planets can't break free of the ultimate group project. Their reward? A front row view of the greatest show in the solar system, and the privilege of saying, we've been dancing for billions of years, and nobody's stepped on anybody's toes, yet. So the next time life feels repetitive, take comfort in the universe's weirdest relationship. You're not alone, and at least you don't have to orbit the same dance floor forever. Unless, of course, you want to. Ever had one of those days where your problems feel weightless, only to realize you're still stuck circling the same old issues? In orbit, that's literally true. Here, you're weightless, but still stubbornly tethered, the universe's answer to, out of sight, but not out of mind. Let's drop you into the middle of this surreal cosmic routine. You're floating inside your spaceship, arms and legs drifting out like a starfish that's just clocked out for the day. Your phone alarms, your half-finished to-do lists, and that weird conversation from 3 days ago, they're all back on Earth, firmly glued down by gravity. But you're the lucky winner of the ultimate spa day. No pressure, no weight, no obligation to sit up straight ever again. Just you, gently drifting in circles above the world's most beautiful screensaver. But here's the catch. You're not actually free. You're just in the most luxurious slow-motion trap the universe has to offer. Sure, you feel weightless. Your arms float, your hair rises, your snacks drift by in poetic slow motion. The world below seems smaller, quieter, blessedly far away. But step outside, and you'll find yourself pulled right back onto the same carousel, forever falling, never landing. Orbit is the art of being stuck, but with better views and lower back pain. Zero gravity is a strange, exhilarating state. For your body, it's like being let off the leash for the first time in your life. Your bones, tired of carrying you around, take a vacation. Your spine stretches out. Your muscles start quietly panicking. No more stairs, no more standing desks. Astronauts say the first few days are a riot. Every move sends you bouncing off walls, spinning like a rotisserie chicken, giggling as droplets of water float past your nose. It's fun until it isn't, because eventually you realize that weightlessness is a cheat code with consequences. Your body's entire system was built for gravity, and without it, things get weird fast. Your bones start losing calcium like a neglected houseplant. Your muscles atrophy, your face puffs up like you lost an argument with a bee, and your sense of balance becomes a memory. Even your heart, the world's most patient pump, has to relearn how to move blood around without the helpful hint of down. And yet, the illusion of floating freedom is powerful. You watch the world drift by a sunrise every 90 minutes, city lights winking on and off, oceans spinning beneath you. Time becomes soft and strange. You eat, you sleep, you play with zero-G yo-yos, all while orbiting the same planet, stuck in a routine that's technically going 17, 0 miles an hour, but emotionally feels a lot like Tuesday. What does this tell you about the universe? That freedom isn't always about cutting ties. Sometimes, it's about learning how to float with the constraints, to enjoy the sensation of weightlessness while knowing you're still tethered to something bigger. The astronaut, drifting through the endless dark, is still caught in Earth's gentle grip. The planet, circling the sun, is just as much a prisoner as it is a free spirit. No matter how light you feel, you're always attached by love, by physics, by a stubborn refusal to drift off into deep space and never be seen again. So next time your worries feel like they're floating away but never quite disappearing, remember, even in zero gravity, you're always in orbit. Problems, like planets, have a way of circling back. And that's okay. It means you're part of the cosmic dance, a little bit stuck, a little bit free, gently revolving above the noise, with a view no one else can claim. Lean into the float, enjoy the spin, and if your snack floats away, just remember, at least your problems aren't the only thing orbiting you tonight. Imagine driving so fast the only cop that could catch you is the sun itself. Orbit is about speed, not just going fast, but going precisely fast enough to dodge the sun's gravitational handcuffs without ever escaping its gaze. Strap in and check your mirrors tonight. You're about to break every terrestrial speed limit. The only law that matters here is gravity, and the consequences aren't just a fine or a stern talking to. In space, it's all or nothing. Go too slow, and you'll spiral straight into the sun like a moth chasing a light bulb. Go too fast, and you'll never see home again, launched into the cold darkness with only cosmic dust for company. To stay in orbit, you have to hit that perfect, just right velocity, the Goldilocks of space travel. Let's set the scene. You're behind the wheel of the ultimate cosmic sports car, a planet, a probe, maybe even a wayward potato if it's moving fast enough. The speedometer doesn't bother with kilometers per hour. Instead, it ticks up in thousands, tens of thousands of meters every second. For Earth's orbit around the sun, you're doing about 30 kilometers per second. That's 67, 0 miles an hour. Forget breaking the sound barrier. You're breaking the sound barrier before breakfast and lapping it by lunch. But here's the weird part. You don't feel fast. There are no trees zipping by, no wind in your hair, no furious honking from impatient galaxies. In space, speed is invisible, pure momentum, pure math, pure trust the process. You're moving so quickly that you're always missing the ground beneath you, always sidestepping gravity's embrace. And yet, you don't get anywhere new. You just keep circling the same old route, lap after lap, year after year, on the universe's longest racetrack. This is the magic of orbital speed. It's not about acceleration, it's about balance. The speed you need to stay in orbit depends on how far you are from the thing you're orbiting. The closer you are to the sun, the faster you have to move to avoid falling in. Mercury, for example, is the reckless teenager of the solar system, zipping around at nearly 48 kilometers per second, while Pluto is the chill retiree, taking it slow on the edge at just under 5 kilometers per second. If you want to escape, you need to go faster still. This is called escape velocity, the minimum speed required to break free from a gravitational pull entirely. For Earth, it's about 11.2 kilometers per second, or roughly the speed of someone who's just realized they left their oven on at home. Hit that number, and you're out. Miss it, and gravity yanks you right back. The sun's escape velocity, by comparison, is an absurd 617 kilometers per second near its surface. That's late for the last flight off the planet fast. But unlike traffic on Earth, there's no police car hiding behind a cosmic billboard, no radar gun pointed your way. The only enforcer here is gravity itself, always patient, always waiting for you to slip up. There's no pulling over for a friendly chat, just the silent, relentless negotiation between your speed and the sun's grip. What does this feel like? If you could look out the window, you'd see the stars standing still, while you, invisible, whip around the sun at speeds that would give any insurance agent a heart attack. There's no wind, no noise, just you, locked into the fast lane, surrounded by the endless, empty quiet of space. It's exhilarating and a little existential, a race you can never win, but can only lose if you stop moving. So, the next time someone tells you to slow down, remember, in space, speed isn't just cool, it's necessary. Keep moving, dodge the handcuffs, and try not to let the sun catch you speeding. You wouldn't like the penalty. What happens if you want to leave the party early? Space has an exit fee called escape velocity. Unless you hit the cosmic speed limit, you're stuck at the sun's soiree for eternity no matter how bad the playlist. Picture this. You've been circling the cosmic dance floor for ages. Your shoes are tired, the snacks ran out after the first billion years, and now the DJ is just playing The Sound of Silence on repeat. You look for the exit, but there's a velvet rope and it's not budging. Welcome to the solar system's most exclusive event, hosted by gravity itself. Getting out isn't just a matter of saying good night and catching a cab. Here, you need energy, speed, and the universe's equivalent of a platinum credit card. Escape velocity is the minimum speed you need to break free from a planet, star, or moon's gravitational grip and head out into the cosmic night. For Earth, it's about 11.2 kilometers per second, roughly 25.0 miles per hour. That's, I forgot my anniversary fast. For the Sun, it's more than 600 kilometers per second. Unless you're a photon or in a serious hurry, you're not making it out easily. Let's break it down. Imagine you're in a car parked at the bottom of a steep hill. You put the pedal down, engine roaring, trying to reach the top. Go too slow, and gravity just rolls you back down, like Sisyphus with better air conditioning. But if you hit the gas hard enough, if you reach escape velocity, you crest the hill and keep going. No more sliding back, no more endless loops. You're free. The party is officially over. But in space, there's no friction, no wind, no sound. Just you, your speed, and gravity's relentless pull. The trick is, you have to reach escape velocity all at once. There's no pausing halfway to catch your breath or fill up on gas station snacks. If you don't hit that magic number, you'll slow down, stall, and fall right back into orbit, doomed to circle the party with the other cosmic wallflowers. This is why rockets are so dramatic. Blasting off from Earth isn't just about going up. It's about going fast, so fast that Earth's gravity eventually gives up, sighs, and lets you go. Every kilogram of fuel, every inch of booster is there to help you pay the fare. And the price? Astronomical. The Saturn V rocket that took humans to the moon burned through millions of pounds of fuel in just a few minutes, all for a one-way ticket past gravity's velvet rope. If you think about it, escape velocity is one of the universe's most brutal cover charges. Want to leave Mars? Different speed. Want to escape the moon? Easier, but still not free. Want to leave a black hole? Don't even try. The exit fee there is infinite, and even light can't afford it. In a cosmic sense, most things are destined to stay put, trapped by gravity's event planners. But there's a flip side. If you do manage to escape, if you summon enough energy, speed, and determination, you get to wander the stars, an interstellar nomad with no reservations. Comets do it. Some asteroids do it. Even the Voyager spacecraft, launched in the 1970s, are now out there, beyond the sun's party zone, destined to float in the dark between stars forever RSVP'd no to every future solar system gathering. So next time you're desperate to bail early on a social event, just remember, at least you don't need 0 miles per hour and a rocket the size of an apartment building to make your escape. On Earth, the price of freedom is just a polite excuse, and maybe a cab fare home. In the universe, it's escape velocity or bust. So what's it like to be in true orbit? Imagine falling off your bed, but never hitting the floor, just an endless soft swoop around a giant fiery nightlight. Bring snacks. There's no landing. Let's start with the moment your stomach realizes something's very wrong. You're not standing, sitting, or even lying down in the usual sense. Your body, so used to being claimed by gravity, is now caught in a perfect, uninterrupted fall. Your brain has no reference point. Your arms, legs, and hair all float around you, like you've just been tossed into a cosmic washing machine set to gentle. There's no ground rushing up to greet you, just an endless feeling of lightness, as if gravity's taken a coffee break and forgotten to clock back in. At first, your body panics. Your inner ear sends frantic texts to your brain, wears down. Your stomach briefly auditions for Cirque du Soleil. But then, something magical happens. Your senses recalibrate, your muscles relax, and you begin to enjoy the ride. You realize you're not in danger. You're not plummeting. You're gliding, endlessly, like the world's most patient skydiver who never runs out of sky. Astronauts describe this as weightlessness or microgravity, but neither word quite does justice to the experience. Imagine everything that normally defines up and down, the tug on your shoulders, the heaviness in your feet, the pull of your face toward your pillow vanishes. You push off the wall with a single fingertip and float for minutes, coasting across the room in slow motion. Want to move up? Just sneeze a little harder. Want to do a backflip? Wiggle. It's the closest thing to flying you'll ever know, minus the feathers. Your day-to-day routine becomes a series of slow, floating dances. Getting dressed is a full-contact sport with your clothes. Every action, eating, sleeping, brushing your teeth, becomes a physics experiment. Water forms floating blobs that drift through the air, daring you to catch them before they become part of your hairdo. Snacks escape their wrappers and orbit your head, waiting for you to chomp them out of midair like a hungry goldfish. Sleep is another story. Without gravity to pull you gently into your mattress, you strap yourself into a sleeping bag attached to the wall, the ceiling, or wherever you please. You close your eyes and float, your limbs relaxed and free, like a very content cat in a sunbeam. The feeling is so soothing that many astronauts report their best sleep ever in orbit if you can get used to the sensation of gently spinning every time you turn over. But don't be fooled. Perpetual freefall has its downsides. Your body, freed from gravity's demands, starts slacking off. Muscles shrink, bones lose density, fluids drift toward your head, making your face puff up in your new astronaut selfies. Your inner ear gives up, and you might feel queasy until your brain adapts. Even your sense of taste changes. Hot sauce becomes the unofficial condiment of space, because regular food suddenly tastes like cardboard. And yet, every time you drift past a window, the sight takes your breath away. The world curves beneath you, a blue marble cradled by the blackness of space. Sunrises and sunsets roll by every 90 minutes, painting your spaceship in wild colors. Your problems, worries, and emails are all somewhere down there, stuck to the surface. Up here, it's just you, the silence, and the endless, gentle swoop. Perpetual freefall isn't terrifying. It's liberating. It's a reminder that falling doesn't always mean disaster, that sometimes, with the right balance, you can fall forever and call it flying. So if you ever get the chance, bring snacks, let go, and enjoy the ride. In orbit, landing is overrated anyway. Not every orbit is a perfect circle. Some are stretched, tilted, or plain rebellious like a planetary midlife crisis. Tonight, you'll ride along as worlds wobble, loop, and generally ignore best practices. If you thought the solar system was a neat and tidy clockwork of planets, each gliding around the sun in polite circles, well, buckle up. The universe loves drama, and the orbits of planets, moons, and everything in between are no exception. Forget your high school geometry. Most orbits are more like those lopsided, wobbly hula hoops that refuse to stay up, swinging wide, dipping close, sometimes turning the whole cosmic dance into a slow-motion demolition derby. Let's start with eccentricity, a word that in astronomy means how much your orbit looks like an egg, and in real life means how much your uncle embarrasses you at Thanksgiving. Earth's orbit is just a little bit squished, which is good for life as we know it. But other worlds take things to the extreme. Mercury's orbit is a show-off, stretched into a clear oval. Pluto's is so elongated, it sometimes cuts in front of Neptune, like it's cutting the cosmic line at Starbucks. Comets? Their orbits are so wild, they spend most of their time hiding out in the icy suburbs, before swooping in for a wild ride around the sun, then vanishing again like that friend who only texts when they need to borrow your lawnmower. Now, add some tilt. Some planets, like Uranus, don't just orbit at a jaunty angle, they spin on their sides, rolling around the sun like a cosmic barrel. Imagine doing laps around the track while also somersaulting end over end. That's a year on Uranus. Venus, meanwhile, spins backwards. No one knows why, but it's the planetary equivalent of arriving at a party, moonwalking through the door, and pretending that's totally normal. Then there's inclination, the degree to which a planet's path tilts relative to the flat plane where most of the action happens. Most of the planets behave themselves, orbiting in more or less the same flat disk, but the solar system's oddballs take their own path. Pluto again wins the prize for most likely to be doing its own thing, circling at a tilt of 17 degrees compared to the rest of the major planets, as if it's perpetually late to the meeting and coming in from the side door. But why do orbits go wild? It's not just for entertainment. Gravitational tugs from other planets, ancient collisions, or close encounters with passing stars can twist, stretch, and torque a planet's path for millions or even billions of years. Space is crowded, and gravity never sleeps. The result? A solar system full of planets on wobbly tracks, moons on roller coaster rides, and comets on mysterious, dramatic journeys. For a human in orbit, these quirks can get personal. Satellites must constantly adjust their path, nudging themselves back on track like someone trying to stay in their lane during a 3-coffee commute. If they don't, they risk drifting into weird, elliptical loops, or even tumbling back to Earth in a fiery finale that nobody asked for. But here's the thing, the universe isn't trying to be chaotic. It's just really, really honest about momentum and gravity. Once an object gets kicked off the perfect circle path, it keeps going sometimes for millions of years before things settle down. Orbits can even swap energy with each other, as if trading cosmic coupons, causing one planet to get a little wilder while another chills out. So the next time your own life feels a bit off-center, or you catch yourself looping around the same problems in weird and wonderful patterns, take heart. Even planets have their rebellious phases. The universe runs on eccentricity, on tilt, on the beauty of almost but not quite. And honestly, it makes for a far more interesting story. Earth's moon is the classic example of clingy, but in a good way. Locked in orbit, it pulls our oceans, lights up our night skies, and occasionally tries to eclipse the sun just for drama. Let's take a moment to appreciate just how wonderfully codependent the Earth-Moon relationship island. The moon isn't some distant, casual acquaintance. It's right there, every night, and sometimes in broad daylight, circling you like a loyal pet with major separation anxiety. Every time you look up and see that silvery disk, you're witnessing one of nature's longest, most committed long-distance relationships, complete with the occasional cosmic spectacle to keep things interesting. For most of human history, the moon has been our nightlight, calendar, and unwitting muse. It keeps the darkness from getting too dark, inspires poets and insomniacs, and messes with werewolves and fishermen alike. But the moon isn't just a pretty face. It's a gravitational force to be reckoned with, tugging at Earth's oceans so persistently that our planet's tides run on lunar time. Twice a day, all that water rises and falls, as if the moon is gently rocking Earth to sleep. If you've ever fallen asleep to the sound of waves, you owe a thank you note to Earth's clingiest companion. But why does the moon hang around? Blame gravity and a little thing called orbital mechanics. The moon is just far enough away that it's caught in a perfect tug-of-war, always falling toward Earth, always moving fast enough to miss. It's the ultimate game of keep-away played for billions of years. But here's the twist. The moon is slowly drifting away. Yep, every year it escapes by a few centimeters, like a teenager inching toward the door at a family reunion, still in the room, but thinking about freedom. Despite its slow escape, the moon is still all in for the drama. Take eclipses. Sometimes the moon lines up just right between Earth and the sun and throws the cosmic equivalent of a blackout party, casting a shadow that races across continents, sending birds to bed early, and giving humans a reason to go outside and stare at the sky. Other times, it photobombs the sun, only covering part of its face, as if winking down at us. Eclipses are a reminder that even in the most predictable relationships, there's always room for a little mystery. Living with the moon's influence isn't always romantic, though. The tides don't just move water, they subtly slow the Earth's spin, like a gentle reminder to chill out and take your time. Because of this, your days are getting longer. Not by much, just a couple of milliseconds every century. Still, if you've ever wished for more hours in the day, thank the moon for making it happen, one slow revolution at a time. And then there's the moon's effect on human hearts and minds. Ask anyone who's worked a night shift or managed a classroom during a full moon, and you'll hear tales of weirdness, restlessness, and inexplicable chaos. Is it just folklore? Maybe. But the moon has been blamed or credited for everything from romance to madness to record sales of night cream. There's something about that bright, round face peeking in your window that stirs the imagination, even if the science is still out. So, next time you're out late, gazing up at that glowing orb, remember, you're not alone. The moon is right there with you, pulling oceans, lighting paths, and sticking around through every phase. Maybe it's clingy, maybe it's loyal. Maybe it just knows a good thing when it's got it. Whatever the reason, Earth's overly attached satellite has been circling us since the beginning, and honestly, the nights would be emptier without it. Sleep easy. The moon's still watching over you. Tidal forces. They're why your feet stay dry and the moon never moves out. These are the universe's version of a gentle gravitational wedgie, stretching, squeezing, and making sure planets never get too comfortable. Let's start by picturing what a tidal force actually island. Imagine gravity as an invisible hand, giving every object in the universe a polite but firm tug. Now, if you're lucky enough to be a planet with a moon or an ocean, or both, gravity gets a little mischievous. It tugs harder on the side facing the moon and a little less on the far side. The result? The entire planet gets gently stretched, like your waistband after a big dinner, but in a much more sophisticated and cosmic way. Tidal forces are the universe's way of making sure nobody gets too relaxed. You feel the results every day, even if you've never waded deeper than your bathtub. As Earth spins, the moon's gravity drags a bulge of water along with it. This creates high tides, two of them actually, one on the side facing the moon and another on the opposite side. The low spots in between? Low tides. Every coastal creature, sandcastle architect, and surfer lives by this schedule, thanks to the moon's endless gravitational shenanigans. But tidal forces don't stop at splashing your beach towel. They're constantly at work behind the scenes, kneading and squeezing not just water, but rock, magma, and even the shape of planets and moons themselves. The moon, for example, used to spin much faster, but over time Earth's gravity grabbed hold, slowed it down, and locked one face of the moon toward us forever. This is why we always see the same side. Earth gave the moon a cosmic wedgie so epic, it turned into a lifelong staring contest. It doesn't end there. Earth too isn't immune. The moon's pull creates friction deep inside our planet, slowly converting some of Earth's rotational energy into heat. It's why our days are getting longer, millisecond by millisecond. Tidal forces are like that friend who insists you take things slow, even if you weren't in the mood for a lazy Sunday. In a few million years, the Earth's day will be longer still, and the moon will have drifted farther away though, at just a few centimeters per year. You don't need to change your calendar just yet. If you think planets and moons have it rough, wait until you meet the real victims of tidal drama, the moons of Jupiter. Io, for example, is yanked and squeezed so hard by Jupiter's gravity that its insides heat up and erupt in constant volcanic tantrums. The result? It's the most volcanically active place in the solar system, and all because of a tidal tug-of-war that never ends. Imagine living with a perpetual stomachache and no way to call in sick. Even stars feel the burn. In extreme cases, tidal forces can shred whole worlds apart. Get too close to a black hole, and the difference in gravity between your head and your toes becomes so extreme that you'd be stretched into cosmic spaghetti, a process scientists affectionately call spaghettification. It's one wedgie you really want to avoid. Back here at home though, tidal forces are mostly gentle. They sculpt coastlines, set the rhythm of life in the sea, and keep our planet-moon duo in a slow, beautiful waltz. They remind us that even the quietest, most subtle forces can shape worlds, drive evolution, and keep things interesting. So, next time you're standing at the edge of the ocean, watching the waves rise and fall, think of the moon and the invisible hand giving Earth a gentle, persistent cosmic wedgie. You might never see it, but you'll always feel its pull. Einstein didn't just give us time dilation, he made going in circles even more confusing. Tonight, you'll discover how space and time warp, so your midnight orbit might be someone else's afternoon nap. Let's set the stage. You're floating through space, circling a planet, lulled by the endless routine of sunrise and sunset every 90 minutes. It should be simple, right? But then Albert Einstein wanders onto the scene, wild-haired, eyes sparkling, carrying the universe's most complicated bedtime story. Suddenly, nothing about orbits, time, or normal makes sense anymore. Einstein's theory of relativity shattered the old rules. Newton told us gravity is a force pulling masses together, but Einstein said, wait, gravity is really space and time, themselves being warped by anything with mass. Picture space-time as a giant trampoline. Put a heavy bowling ball in the center, that's your sun, and the fabric dips. Planets, moons, and even you, if you're floating up there, are like marbles, rolling around the dip. You're not being pulled by gravity. You're following the curve, doomed to circle forever like someone who can't find their way out of a roundabout. But here's where your insomnia kicks in. Time itself bends in the presence of mass and motion. The closer you are to a massive object, or the faster you're moving, the slower your clock ticks compared to everyone else's. You might think that orbiting Earth at blistering speed is just a cool way to rack up frequent flyer miles, but according to Einstein, it's also a way to time travel very slowly. Let's say you're an astronaut, zipping around Earth on the International Space Station. Your day is chopped into 16 sunrises and 16 sunsets. But because you're moving so fast and sitting just outside Earth's deepest gravity, time for you is ticking ever so slightly slower than for your friends down below. Stay up there long enough, and you'll return to Earth the tiniest fraction of a second younger than everyone else. Space's version of a free anti-aging treatment. This isn't science fiction. It's real science, and we actually have to account for it. Your GPS relies on satellites that orbit Earth, and they tick faster than clocks on the ground because they're farther from gravity's dip and moving fast. If engineers didn't correct for relativity, your GPS would send you in circles, maybe all the way to a different time zone. So next time your phone gets you to the right coffee shop, Whisper a quiet, thanks to Einstein. But relativity doesn't just affect clocks. It warps what you see. If you watch someone orbiting near a massive planet, their motions will appear to slow down as they get closer to the gravitational dip. If you could see someone orbiting the edge of a black hole, their clock would seem to nearly freeze compared to yours, while they'd still feel time ticking along as usual. It's the ultimate cosmic prank. Nobody experiences time the same way. So, as you float endlessly around your midnight planet, remember somewhere else in the universe, someone else's midnight is actually afternoon or breakfast, depending on how fast and how deep into gravity's well they are. Einstein took the simple, soothing circle of orbit and turned it into a Mobius strip of confusion, beautiful, strange, and guaranteed to keep philosophers and night owls awake. What does this mean for your sleep? Well, maybe it's not your fault if you can't keep track of time anymore. Maybe it's just relativity. Maybe you can tell your boss you're not late, you're just on Einstein time. So the next time your insomnia has you circling the kitchen at 3 a.m., remember, in a universe where time itself can warp and bend, maybe there's no such thing as the wrong hour. Good night, wherever, whenever you are. There's a sweet spot in every solar system, not too close, not too far, just perfectly orbital. Welcome to the cosmic real estate market, where planets fight over the coziest spots for life and beach views. Imagine you're browsing the universe's hottest housing listings. Each star system is its own peculiar neighborhood, and every planet is hunting for that elusive address where the thermostat never swings too wild, the sunlight is just right, and you don't have to worry about boiling away or freezing your atmosphere before breakfast. In planetary terms, this is called the habitable zone, or because astronomers love a good fairy tale, the Goldilocks zone. Not too hot, not too cold, but just right. Earth, naturally, is the gold standard of Goldilocks. Our orbit keeps us at a polite, respectful distance from the sun, close enough to bask in the glow, but not so close that our oceans boil away like a neglected tea kettle. We're not shivering on the solar outskirts either. Our blue world sits in the prime location, with front row seats to the only star we'll ever need, unless you count that one neighbor with the suspiciously bright porch light, aka Venus. But not every planet is so lucky. Some worlds huddle too close to their sun, where the beachfront comes with complimentary lava, perpetual daylight, and a strict no oceans allowed policy. Mercury and Venus are classic examples. Real estate's so hot, even your sunscreen would melt. On the other side, you've got the cold cases. Mars, the original fixer-upper, and the icy moons way out in the dark, where the biggest challenge is finding a working furnace. Being in the Goldilocks zone isn't just about temperature, though it's about the potential for liquid water. Astronomers are obsessed with H2O, because wherever we find water on Earth, we find life. From the steamiest hot springs to the coldest Antarctic lakes, and even the slightly alarming puddles in your gym bag. If a planet can keep water in its liquid state, it's won the cosmic lottery, a place where chemistry gets weird, where oceans might shimmer, and where, just maybe, something with a nervous system could be out there sipping stardust and contemplating taxes. The best part? This real estate market is more crowded than we once thought. In the past few decades, astronomers have found thousands of exoplanets, worlds orbiting distant stars, some even in their own Goldilocks zones. Some of them are bigger than Earth, some smaller, some orbiting twin suns like Tatooine, and some with entire systems of moons that might be more just right than their own planets. But the Goldilocks zone is a moving target. Stars get brighter as they age, planets wobble, orbits can stretch and shrink. Earth, for example, wasn't always so cozy. There were times when glaciers wrapped the planet like a giant snowball, and times when the poles were warm enough for palm trees and crocodiles. The lesson? Even in the perfect spot, climate is always a work in progress. It's humbling and a little thrilling to realize just how narrow the window. Island move a little closer to the sun, and the world becomes a sauna. Drift a bit farther, and it's an endless winter. Earth orbits in this cosmic Goldilocks zone, not by luck alone, but by billions of years of delicate balancing acts, volcanoes, asteroids, tectonic tantrums, and the occasional well-timed mass extinction. So, next time you grumble about the weather, remember, in the grand scheme of things, you live in the solar system's prime real estate. There's no guarantee the lease will last forever, but for now, it's not too hot, not too cold, just orbital, and just right. Good night from the coziest corner of the cosmos. Solar systems are busy highways. Sometimes planets, asteroids, and comets share the same orbital lanes, causing traffic jams, near misses, and occasionally galactic fender benders. Forget the image of a lonely planet serenely circling a quiet star. The reality is much more like rush hour, if rush hour involved flaming debris, a few lost moons, and everyone moving at tens of thousands of miles per hour. The solar system, far from empty, is packed with cosmic commuters. Each one follows its own carefully calculated path, until something doesn't go quite as planned. Let's start with the asteroid belt. Nestled between Mars and Jupiter, it's the universe's answer to the world's worst roundabout. Millions of rocks, some as big as cities and some the size of your kitchen table, all loop the sun in a region that's just crowded enough to keep things interesting. Most days, they keep a respectful distance, but sometimes, thanks to gravitational nudges from Jupiter or a cosmic game of bumper cars, bits of space rock change lanes, crossing paths, and occasionally sending a meteor our way for some unscheduled fireworks. Then there are the comets, icy outsiders from the far reaches of the solar system, plunging inward on long, looping orbits. They're the flashy sports cars of the cosmic highway, making rare, dramatic appearances before vanishing for centuries. Some comets, like Halley's, swing by on schedule, waving their glowing tails before darting off to the suburbs. Others show up unannounced, with orbits so unpredictable they could teach Google Maps a thing or two about chaos. But it's not just asteroids and comets you have to watch out for. Sometimes, even planets have close encounters. Take Neptune and Pluto. For part of their orbits, Pluto actually swings inside Neptune's path, a move so bold it would earn a ticket anywhere else. Fortunately, the two never crash, thanks to a gravitational handshake that keeps them perfectly out of sync, the cosmic equivalent of after you, no after you. Their paths interlock so elegantly that they avoid collision by a margin that's both precise and poetic. Moons also crowd the lanes. Jupiter and Saturn collect them like cosmic keychains, each with dozens or more, all jockeying for space. Some moons have orbits so close they tug at each other, causing wild swings, volcanic eruptions, or if they get too close, a dramatic breakup that leaves a ring of debris. Saturn's beautiful rings, remnants of ancient moons that strayed into the wrong lane and got shredded by gravity's rules. Even here on Earth, we're not alone in our orbital neighborhood. Each year, thousands of human-made satellites join the party, zipping around at different altitudes and speeds, all while ground controllers do their best to prevent accidental meetings. The result? Space agencies track millions of bits of debris, like a cosmic version of air traffic control. And yes, every now and then, something collides, leaving behind more debris and a flurry of awkward emails. Why so much traffic? The answer is simple. Gravity only gives you so many highways to choose from. Stable orbits cluster together, creating natural lanes where objects gather, like commuters on the only road into the city. But gravity also never sleeps. One small nudge, a passing asteroid, or a wayward spacecraft, and the neat order can turn into a cosmic pileup. Yet, for all the chaos, the solar system manages an impressive balance. Collisions are rare, and most objects keep to their lanes for billions of years. It's the ultimate, high-stakes ballet, each world, rock and ice ball, choreographed by gravity, inertia, and the occasional accident. So next time you're stuck in traffic or navigating a crowded street, take a little comfort. Out there, planets and rocks have been sharing the road for ages. And somehow, most of them are still in one piece. Some planets lap the sun in a few months, others take centuries. Tonight you'll ride shotgun with Mercury, the speed demon, and Pluto, the slowpoke at the back of the pack, and ponder cosmic patience. Imagine the solar system as the universe's strangest racetrack. The starting gun fired about 4.5 billion years ago, and ever since, each planet has been doing laps around the sun, no pit stops, no shortcuts, and definitely no finish line. But unlike your local fun run, not everyone is running at the same speed. It's less ready, set, go, and more ready, set, let's see who brings snacks and who brings existential dread. At one end, you've got Mercury, the reckless little sibling of the solar system. Mercury is so close to the sun it practically needs SPF 10-0, and it sprints around the star in just 88 Earth days. 1 year on Mercury is shorter than 1 season on Earth. Blink, and Mercury has already lapped you, thrown shade at Venus, and asked for another round. It's the cosmic equivalent of the co-worker who's already finished their tasks while you're still opening your first email. Then there's Venus, hot, slow, and spinning the wrong way, but that's a story for another night. Earth takes a tidy 365 days to circle the Sunday. Mars needs almost 2 Earth years, which means if you were a Martian, you'd be aging at half the speed. That's one way to stretch out your vacation time. But let's look farther out, to the giants. Jupiter, the heavyweight champion, lumbers through its orbit in almost 12 Earth years. Saturn, with its elegant rings and laid-back vibes, takes nearly 30 years. If you ever feel like time is slipping by too quickly, just remember, on Uranus, a single orbit is 84 years, long enough for you to live, retire, and still never see a Uranian New Year's party. And then there's Pluto. Yes, Pluto, the underdog, the wallflower at the back of the class. Whether or not you call it a planet, Pluto has the patience of a saint, taking 248 Earth years to complete a single lap. By the time Pluto finishes one orbit, Mercury has raced around the sun nearly 132 times. Earth has had 2 world wars, and at least one fashion trend has come back into style. Why such wild differences? It's all about distance and gravity. The closer a planet is to the sun, the stronger gravity's grip, and the faster it has to move to avoid falling in. The farther out you go, the weaker that grip, and the more leisurely you can take your trip. Planets obey Kepler's laws, which state, in sleep-friendly terms, that the farther away you are, the slower your speed and the longer your year. It's like cosmic traffic. Rush hour up close, Sunday drive at the edge. These differences aren't just numbers, they shape everything. Fast inner planets experience dramatic changes, intense heat, and wild solar storms. The slow outer worlds have longer seasons, thicker atmospheres, and enough time to host an ice age or two before the next birthday. And yet, everyone's moving, everyone's circling, no matter how fast or slow. The great planetary race is less about winning and more about finding your pace, settling into a rhythm that might last for billions of years. Mercury burns out quickly, Pluto takes its sweet time. The rest of us are somewhere in between, doing our own laps, at our own speed. So next time you feel rushed or impossibly slow, just remember, in the solar system, there's no perfect pace. Whether you're Mercury or Pluto, everyone gets where they're going eventually. Take a breath, enjoy the ride, the race goes on, and there's always time for another lap. Every so often, a planet appears to moonwalk across the night sky. Is it lost? Just showing off? Or is it a celestial scheduling glitch? Retrograde motion is the universe's answer to the unread email badge. If you've ever gazed up at the night sky and thought, wait, wasn't Mars over there last week? Congratulations. You've witnessed retrograde motion, the original cosmic plot twist. It's the astronomical equivalent of your GPS suddenly recalculating and suggesting a U-turn, only to drop you right back on your old route. To ancient astronomers, It looked like the planets were going about their business, then suddenly losing all sense of direction and moonwalking backwards for a few weeks before carrying on as if nothing happened. Nothing to see here, just ignoring the laws of cosmic traffic. So what's really going on? Spoiler alert, planets aren't actually reversing or slamming on their celestial brakes. Retrograde motion is a trick of perspective, a beautifully orchestrated optical illusion served up by the universe to keep skywatchers humble and astrologers in business. It happens because Earth, in its speedy inside lane around the Sun, occasionally overtakes an outer planet, like Mars or Jupiter, on its cosmic racetrack. Imagine you're driving on a multi-lane highway. You pass a slower car in the next lane. For a moment, it looks like the other car is moving backward, even though you both know it's still going forward. That's retrograde motion, not a sign of planetary confusion, but of you, the observer, getting a new perspective. When this happens, a planet like Mars appears to slow down, stop, and move backwards against the backdrop of distant stars. Ancient skywatchers found this deeply suspicious. What could it mean? Was Mars plotting something? Did Jupiter get stage fright? The answers eluded humanity for millennia, spawning elaborate models with gears, epicycles, and enough circles within circles to make your head spin. It wasn't until Copernicus came along bravely suggesting that the Sun, not Earth, was at the center of the show that retrograde motion finally made sense. Once you realize Earth and the other planets are all orbiting the Sun at different speeds and distances, the weird backwards dance is just a natural side effect. No magic, no mayhem, just cosmic choreography. But the illusion remains strangely captivating. Even now, people blame retrograde motion for everything from bad hair days to tech disasters to awkward family dinners. Mercury's in retrograde has become the universal excuse for every missed text and weird mood swing. Astronomically, though, it's nothing personal. It's just a reminder that perspective shapes everything, especially in the universe. From a sleep story perspective, retrograde motion is oddly soothing. It's proof that even when things look out of order or seem to be going backwards, it's all just part of a larger, invisible plan. The planets know what they're doing, even if, from our limited perch, it sometimes looks like they're retracing their steps, reviewing their notes, or desperately searching for their lost car keys. So, the next time you spot a planet moonwalking through the stars, don't worry, the universe hasn't hit rewind. You're just getting a front row seat to one of its oldest, quirkiest magic tricks, a lesson in patience, perspective, and not believing everything you see. And if you're still haunted by that unread email badge, just remember, even Mars gets stuck in reverse sometimes. Take a breath, change your perspective, and let the universe handle the rest. Perfect circles are for geometry class. Out here, orbits stretch into ellipses, squashed like cosmic rubber bands, giving every planet its own personal roller coaster. If you imagine the planets gliding serenely around the Sun on tracks as perfect as a compass drawing, think again. The universe loves a little chaos, and apparently, it hates boring circles. Most orbits, from planets to comets, to that slightly anxious space probe from the 1970s, follow paths that are stretched, squashed, and sometimes look like they were designed by someone who never quite finished art school. Enter the ellipse, the shape that says, "I tried to be a circle, but life happened." An ellipse is what you get when you take a circle and gently squish it, like a pizza dough you forgot to roll evenly. Technically, it's defined by two special points called foci, fancy math word for not quite the center. In our solar system, the Sun sits at one of those foci, not at the very center. That means that as a planet travels its path, it sometimes swings closer to the Sun, the perihelion, and sometimes drifts farther away, aphelion. Like a roller coaster car racing up and down the track, Earth's orbit is almost, but not quite, circular. It's the Goldilocks of ellipses, just enough eccentricity to keep things interesting, but not enough to make us seasick. If Earth's orbit were a dance move, it'd be the cautious two-step, never straying too far, never crowding the sun's personal space. But head to Mercury, and you'll find an orbit that's noticeably more squashed. Pluto? Its path is so elongated that it sometimes cuts inside Neptune's lane, then drifts back out like the world's least punctual party guest. Comets take elliptical orbits to the extreme. Their paths are long, stretched ovals that swing them from the icy darkness on the solar system's edge to a wild, blazing dash around the sun, then back out again like cosmic thrill-seekers on a schedule only they understand. When you see a comet with a dramatic tail streaking across the sky, it's at the point in its ellipse where it's closest to the sun, showing off before disappearing for decades or centuries. But why do orbits get so elliptical? Blame the simple, honest math of gravity and motion. If you launch an object around a star with just the right speed and angle, you get a nice, tidy circle. But give it a little extra nudge, or send it off at a weird angle, and you've got yourself an ellipse. Over time, gravitational nudges from other planets, passing stars, or the occasional interstellar collision stretch those circles into all sorts of cosmic shapes. Living on a world with an elliptical orbit means your distance to the sun changes slightly as you travel through the year. For Earth, the difference isn't much, just enough to make for a few science trivia nights. But on Mars, it means longer, harsher winters and shorter, more intense summers. On some exoplanets, it means wild swings between boiling and freezing, as if the planet can't decide which season fits its vibe. But there's beauty in this imperfection. Elliptical orbits give us variety-changing seasons, spectacular comet shows, and the comforting knowledge that, even on a cosmic scale, nobody's perfect. Sometimes, the universe takes the scenic route, loops wide, or swings close, just to keep things interesting. So, if you ever find your own life veering off the circle, stretching out of shape, or feeling a bit like a rubber band pulled between deadlines, remember, even planets take the elliptical path. The ride may be a little bumpier, but the view is always worth it. Settle in, enjoy the loops, and trust the orbit. What happens when gravity just gives up? If a planet strays too far, or if a passing star muscles in, that world can get flung into the void, a cautionary tale about overextending yourself. Imagine you're at a dance party that's been going on for billions of years. You and your friends, planets, moons, the occasional sassy comet, are all circling a central figure, the sun, moving in perfect-ish harmony. But sometimes, the music changes. Maybe you wander a little too far from the center. Maybe someone new arrives, pushing you out of your carefully choreographed groove. Suddenly, you're not part of the circle anymore. You're adrift, alone, spiraling into the dark. Welcome to the world of lost orbits, the universe's version of being unfriended in the most dramatic way possible. Losing orbit doesn't happen often, but when it does, it's usually spectacular. It takes a lot for gravity to give up on something. The rules are strict. As long as you move at just the right speed and distance, gravity will keep you close. But the universe is full of cosmic troublemakers, wandering stars, massive planets, lurking black holes, each capable of giving a planet the nudge it never asked for. Let's say a star passes too close to a solar system. Its gravity can yank a planet or comet right out of orbit, sending it on a one-way journey through the endless, silent dark. It's a bit like being in a group text when someone new joins and all the conversations get weird, except, in this case, you end up alone in interstellar space with nobody to text at all. Sometimes, the culprit is a nearby giant planet. In the early days of our solar system, Jupiter and Saturn likely played cosmic billiards, tossing smaller worlds and asteroids out into the void, or hurling them into the sunday. Even today, a passing asteroid or rogue planet can disrupt the delicate balance, booting something out of orbit and onto a new, lonely path. Scientists believe there are billions, yes, billions of rogue planets wandering the galaxy, each a reminder that even gravity has its limits. What's it like to be one of these cosmic castaways, Free, in a way no star to orbit, no curfews, no solar flares to ruin your day, but also cold, dark, and isolated. Without a sun, there's no light, no warmth, and no seasons. It's the ultimate introvert fantasy, or maybe just what happens when you RSVP, maybe, to every cosmic invitation for a few billion years. But not all hope is lost. Some wandering worlds might eventually get captured by another star's gravity, joining a new solar system and starting the orbiting dance all over again, proof that sometimes a breakup just means a fresh start. Others drift forever, silent witnesses to the galaxy's history, passing through interstellar space with only comets and cosmic dust for company. Of course, you don't have to be a planet to know what losing orbit feels like. Maybe you've drifted from an old friend group, changed jobs, or outgrown a routine. Sometimes you leave, sometimes you're pushed, and sometimes gravity just lets go. It's a little unsettling, but also an opportunity, a chance to find a new rhythm, or to appreciate the beauty of moving freely, even if it's not where you started. So, the next time you feel like you've been flung out of your usual circle, remember, you're in good company. The universe is full of drifters and wanderers, each on their own epic journey. And who knows? Sometimes, losing orbit is just the first step toward finding your own place in the vast, starry unknown. Float on, cosmic traveler. The universe is wide, and the adventure never ends. Ever wondered why some planets hoard moons like cosmic souvenirs? Tonight, Saturn's rings, Jupiter's moons, and even Pluto's tiny friends show how orbits can get downright crowded. If planets were people, the outer giants would be those friends who never throw anything away. Jupiter, Saturn, Uranus, Neptune, these worlds are the pack rats of the solar system, collecting moons, rings, dust, and anything else that happens to wander too close. Where Earth has one loyal companion, Jupiter has at least 95 moons and counting. Saturn's got 146 plus the most extravagant set of rings this side of a wedding planner's fever dream. But why do some planets end up with moon collections while others barely have one to their name? It all comes down to mass, gravity, and a knack for attracting cosmic company. The bigger a planet is, the more gravitational pull it has, and the more likely it is to capture passing rocks, ice balls, or even would-be asteroids. Some of these moons formed alongside their parent planets, built from leftover material swirling in the primordial disk. Others were captured later, cosmic hitchhikers that wandered a bit too close and found themselves stuck in orbit, like a guest who shows up for dinner and never leaves. Take Jupiter's largest moon, Ganymede. It's so big it could almost be a planet in its own right, larger than Mercury, with its own magnetic field and internal ocean. And then there's Io, a volcanic drama queen who can't stop erupting thanks to Jupiter's relentless tidal tug. Europa, Callisto, Amalthea, Himalaya, the names read like a galactic yearbook, each moon with its own story, each playing a part in Jupiter's ongoing soap opera. Saturn takes a different approach. Its rings are made up of billions of ice particles, some smaller than a snowball, others the size of a house. These icy bits didn't quite make it into a moon, torn apart by Saturn's gravity before they could ever join the big leagues. The result is a glittering flat disk of cosmic confetti, so bright and beautiful you can see it with a backyard telescope on a clear night. Saturn's moons are just as diverse, from giant Titan, with its smoggy orange skies and methane lakes, to tiny potato-shaped Pan, forever plowing a gap in the rings like a snowplow on a wintry morning. But it's not all drama and grandeur. Some worlds are more modest. Mars has two little moons, Phobos and Deimos, that are probably captured asteroids, lumpy and pockmarked, more borrowed than born. Even Pluto, out on the solar system's icy edge, has a handful of companions: Charon, Styx, Nix, Kerberos, and Hydra. Charon is so large compared to Pluto that they actually orbit a point in space between them, waltzing together like dance partners who can't decide who's leading. What about Earth? With only one moon, our night sky might seem a little lonely, but our lunar companion is the perfect size, not too big, not too small. It keeps our planet stable, tugs at our tides, and makes sure our axis doesn't wobble so much that the weather turns truly chaotic. In the grand scheme of things, sometimes less is more. And yet, there's a certain beauty in a crowded orbit. Moons tug at each other, rings shimmer in the light, and every planet tells a different story of cosmic companionship. Sometimes they collide, sometimes they drift away, but for a few billion years, at least, they're together, an astronomical family portrait. So next time you see Saturn in the sky, remember, you're looking at the ultimate collector, a planet that proves there's always room for one more cosmic friend. And if you ever feel your own life is a little too crowded, just remember the universe wouldn't have it any other way. Need a break? The solar system's got rest stops, Lagrange points where you can park your spaceship and watch the world go by without ever burning fuel. It's like napping in the fast lane. Picture this. You're on a cosmic road trip, zipping around the sun, hungry for a snack, and maybe a little existential contemplation. Just when you think you can't go another 1,000,000 kilometers, you spot a miraculous sign, Lagrange point rest area, next exit. Welcome to the solar system's secret parking spaces, where gravity does all the work and you can drift in peace, no engine required. Lagrange points, named after the mathematician Joseph Louis Lagrange, who probably just wanted a quiet place to finish his equations, are special spots in space where the gravitational forces of two massive objects like the Earth and the Sun, or the Earth and the Moon, balance out perfectly with the motion of an orbiting object. It's the universe's version of putting your car in neutral on a perfectly flat hill. No rolling forward, no sliding back, just effortless coasting. There are 5 of these magic parking spaces in every two-body system, each with its own personality. Lone, L2, and L3 line up like cosmic mile markers, one between the two big bodies, one just beyond the smaller one, and one hidden on the far side of the larger one, as if playing interplanetary hide-and-seek. L4 and L5 are off to the sides, forming perfect equilateral triangles with the two main masses, a celestial geometry trick that would make your high school math teacher proud. The most famous Lagrange points are Earth's. Lone is a favorite hangout for solar observatories like SOHO, which sits there watching the sun for solar storms and warning us when it's time to unplug our electronics. L2 is the current home of the James Webb Space Telescope, where it can stare into deep space without pesky sunbeams or earthshine getting in the way. L4 and L5. They're chill gathering spots for Trojan's clouds of asteroids that have set up camp, content to drift alongside the Earth on its journey around the Sunday. But Lagrange points aren't just for astronomers and robots. They're potential pit stops for future explorers, places to park a space station, store extra supplies, or hang out in orbit for a while, letting gravity and inertia do the heavy lifting. In theory, you could set up a cosmic coffee shop at L4 and watch the universe pass by, all without burning a drop of fuel. It's not just the Earth that has these rest stops. Every planet-moon, planet-star, and even some planet-asteroid pairs come with their own set of Lagrange points. Jupiter's are especially popular. Its L4 and L5 points are packed with Trojan asteroids, like commuters crowding the world's most exclusive parking lot. Saturn, Mars, Neptune, everywhere you look. There are cosmic hitchhikers making the most of these gravitational loopholes. Of course, not all Lagrange points are equally restful. Some are a little twitchy. If you drift even a little, gravity will nudge you away, and you'll have to use your engines to get back. But the stable ones, especially L4 and L5, are true sanctuaries. Park there, and you can relax, knowing the universe will keep you on track. So the next time you're stuck in traffic, or looking for a break from the constant hustle, imagine finding your own personal Lagrange point, a hidden rest stop, perfectly balanced, where you can watch the cosmic scenery without lifting a finger. The universe, it turns out, has built-in places for a nap, a snack, and a chance to just float. And in a solar system that never stops moving, sometimes that's the most peaceful place of all. Orbiting a black hole is the universe's ultimate thrill ride, beautiful, terrifying, and likely to end with your atoms rearranged. Tonight, you'll swing near the edge without the existential dread, hopefully. Picture this. You wake up and find yourself strapped into the wildest carousel imaginable. No pastel horses, no cheerful music, just you, the void, and a pitch-black sphere surrounded by whirling streaks of starlight. Welcome to the neighborhood of a black hole, a place where gravity doesn't just tug gently at your feet, it stretches, squeezes, and flings you around with the enthusiasm of a toddler on a sugar rush. Black holes aren't just massive, they're extreme. Imagine squeezing the mass of several suns into an area no larger than your city. The result? A pit in space-time so deep and steep that once you get too close, not even light can escape. That's the event horizon, the ultimate do-not-cross line of the universe. On this thrill ride, the price of admission is your sense of direction, your trust in physics, and, quite possibly, your structural integrity. But before you panic, let's take a slow lap. Far enough from a black hole, you could, in theory, orbit just as you would around a planet or star. Gravity tugs you toward the center, your sideways speed keeps you from falling in, and you whirl around in a perfectly stable loop just with a view no vacation rental could ever match. The stars warp and swirl, their light bending around the black hole's gravity like water around a rock. This is gravitational lensing, and it's as gorgeous as it is unsettling. Every sunrise and sunset blends together into a ring of fire, an endless spectacle visible only from this most exclusive and risky of vantage points. Get a little closer though, and things get strange. Time itself begins to warp. From your perspective, your watch ticks along normally, but to an outside observer, you're slowing down, your orbit drawn out, stretched by gravity's weirdest party trick. The closer you are to the event horizon, the weirder it gets. Stay long enough, and the outside universe will seem to speed up. Years, centuries, even millennia could pass, while for you, it's just a lazy afternoon. But don't get too comfortable. Push your luck, and you'll discover why this is the scariest merry-go-round of all. There's a limit called the innermost stable circular orbit, ISCO, inside which you simply can't keep circling. Cross that invisible line, and you spiral in, powerless to escape. The ride ends, not with a gentle landing, but with a one-way ticket past the event horizon, where all bets are off and the physics textbooks start filing complaints. And then there's spaghettification, the process with a name so silly it almost distracts you from the horror. If you fell toward a black hole feet first, gravity would pull on your toes much harder than your head, stretching you out like cosmic taffy. Astronomers coined this term for good reason. It's a fate reserved for only the bravest explorers and the most unfortunate matter, yet for all its dangers, orbiting a black hole is a marvel, a place where the universe shows off its strangest colors. In the heart of some galaxies, supermassive black holes anchor entire cities of stars, their gravity shaping cosmic evolution itself. These ultimate merry-go-rounds may be terrifying up close, but from afar, they're engines of creation, sculpting the galaxies we call home. So tonight, as you drift into sleep, imagine swinging past the edge of the abyss, unafraid, unscathed, a silent witness to the most mysterious dance in the cosmos. Orbiting a black hole might not make for a relaxing holiday, but as a thought experiment, it's the universe's most thrilling bedtime story. Ever daydreamed about flinging your coffee mug into space and watching it orbit the office? Physics says, nice try. Tonight, we mourn all the everyday objects destined for gravity's eternal embrace. Let's admit it, we've all had moments, usually around our third cup of coffee, where we imagine hurling our mug across the break room and watching it do something dramatic. Maybe it soars in a perfect arc, maybe it miraculously hovers above your desk, or maybe just maybe, it sails right out the window and begins a majestic orbit around the office, spinning like a tiny ceramic moon, immune to meetings and Monday mornings. If only life worked like that. But gravity is relentless, and the universe is not interested in your daydreams of orbital office supplies, unless you're willing to launch your mug at escape velocity. Hint, that's about 200 meters per second for Earth, roughly 25,000 miles per hour. Your trusty mug is destined to plummet to the floor, meeting its fate with the grace of a dropped scone. No matter how hard you throw, no matter how desperate your need for caffeine-based spectacle, physics will always win. The mug falls, the coffee spills, and your co-workers give you that look again. Orbit, after all, isn't just about throwing something hard enough. It's about achieving the right balance between speed and direction, at just the right altitude, so that the object's endless fall matches the curve of the world below. Anything less, and gravity yanks it straight back. That's why astronauts don't simply toss things out the airlock and watch them circle the station. They need rockets, calculations, and the kind of teamwork that doesn't end with a sticky carpet. For most of the stuff in your daily life, orbital dreams are strictly off-limits. Pens, phones, sandwiches, each one doomed to obey the same universal rule. What goes up must come down. Even with your most dramatic office chair spin, the best you'll achieve is a slightly bruised shin and a healthy respect for Newton's laws. But why does this feel so unfair? Maybe it's because we see the universe filled with things in orbit, planets, moons, space stations, satellites, and the occasional unlucky wrench from a careless astronaut. They make it look so effortless, floating serenely, never crashing, never needing a break. Meanwhile, our attempts to achieve even a tiny fraction of that elegance end in gravity's reliable embrace. Still, there's comfort in this relentless order. Gravity keeps our mugs on our desks, our shoes on our feet, and our dinner on the table most of the time. It keeps the oceans at sea level, the air wrapped around our planet, and our houses firmly on the ground, even when it feels like the universe is just a little too obsessed with bringing us back down to Earth. If you ever want to test gravity's grip, you could try an experiment safely, please. Drop a piece of paper, a pen, and your mug from the same height. Spoiler alert, they'll all fall at the same rate, neglecting air resistance, because gravity doesn't care about your attachments or caffeine addiction. It's one of the few things in life that treats everything with perfect, uncompromising equality. So tonight, as you sip your last cup, give your coffee mug a little nod of respect. It's not lazy, it's just a loyal subject of gravity, destined for a life on the ground, supporting your sleepless ambitions one cup at a time. And if you're still daydreaming about orbit, remember, sometimes it's better to keep your feet and your mug firmly planted, knowing the universe's rules aren't there to frustrate you. They're there to keep everything and everyone together. Rest easy, earthbound traveler. The mug stays, and so do you. So tonight, as you tuck into your clean bed with steady gravity and air that stays politely inside your lungs, maybe whisper a quiet thank you to physics for keeping your organs anchored, your dinner on your plate, and your feet, more or less, on the ground. Because out there in the cosmic ballet, everything is falling and missing, spiraling and looping, locked in dances stranger than anything you'll see at your next office holiday party. Planets, moons, comets, even lonely satellites, all kept in line by the universe's invisible rules. Some manage perfect circles, some wobble, some break up and float into the void, which is basically what happens to your social plans after age 35. But here, on Earth, you get the miracle of a full night's sleep, gravity keeping your blanket on, and coffee that stays obediently in its mug. The universe may be absurd, but somehow, you're right where you belong. Good night, cosmic traveler. Sleep tight, and remember, no matter how many orbits you make around the sun, there's no place quite like home.